about 60–70% of the X-axis ball screw assembly, which is quite a work of art actually. I'm quite happy with that. So without more ado, we'll get on with it. Okay, so you can see I've got the mill together a bit now. I've gone as far as I wanted to go with the y-axis. Now I want to, shall we say, make all the parts for the x-axis down to the motor housing or extension. So what I need to do now is make a connection between this across slide and this ball nut. And as you can see, I've machined around the ball nut. There we go. Machined around the ball nut there to enable it to be able to enable it to fit up through there like this. You see that? Okay. So what I need to do now is make an aluminium housing, extension housing, to extend the, shall we say, the clamping device, or the actual, shall we say, the finger or the claw that actually gets put in here, and there's two little screws here that clamp it, and it is semi-adjustable, because not all of these are exactly the same. They may differ in their position in relation to the bearings on the end plates by a millimeter or so, 1/16 of an inch. Can be as much as that. So you need some adjustment for the center of the screw in relation to the bearings on the ends. That is the idea of the clamping method, rather than a bolted method that has no adjustment. So what we're going to do now is make an odd shape. The actual shape of what I've ground away there, because this is very, very hard steel, and it's easy for me just to grind that away, but you've got to be careful grinding that away. What I will do is I will supply a shaped ball nut to fit this particular part. So what I need now to do is to machine an odd shape. Now I'm going to do this not on a CNC machine. The reason being is because it's quite a depth. It's 40mm. What's that, 1.5 inches or something in depth, and when you start getting that deep with the CNC router, you can get quite a bit of tool flex, although it will do it, but I want it done a bit quicker, and I think maybe more interesting for you to see it done on a manual machine. So that's what I'm going to do now. So what I've done is I've roughed this piece out on the lathe, and I'll tell you exactly what I did. Bored the inside out to the correct size. Put this in here. I just simply drew around it. Okay. And in the lathe as well, I put it back in the lathe, and I've turned it down to a diameter that I'm happy with, slightly larger than what the exterior diameter of the nut flange is. Now what I'm going to do now is I'm going to put it into a rotary table on the standard manual mill, and we're going to machine this shape out. It's fairly simply done, and this is how things used to be done before CNC machines. Okay, so this is my manual milling machine. So the action is here that you put, this is like a lathe chuck, and this is a rotary device. Okay, so it's precision made. This would be the 4th axis on a CNC machine. Of course, this is a manual machine, so it does this sort of motion. Now you can mount this set up like this, or you can mount it horizontally to do the different machining processes. So this is how things used to be done before CNC, to make a weird shape then. So that's what we're going to do now. We're going to machine here. This is an 18 mil 4-flute end mill, and we're going to take the table over, bring the tool down, start cutting here, and take a millimeter or so off at a time. Cut from here to here in a rotary action. So that's what we're going to do now, all the way down 40 millimeter. The only thing with this process, it takes some considerable time. This could take probably half an hour or more. So here we go. So you can see the action now. A lot of physical work with this, though, that's the only problem. So I won't bore you anymore, and I'll continue with this now and do it all the way down for 40 mil. Okay, so perhaps you can see now quite a work of art that little bit of a mounting block is there. And if you notice on the underside here, this actually reaches through to the grub screw in there, which locks this up into here. So it is it's fully adjustable. When I say adjustable, you can actually put shims in down behind here, which these are the shims that I've made up. It's just a simple shim type material, and you can put in here one side or the other or in the middle, and then clamp this down. Clamp this down then as you normally would, and it will actually you can actually move the screw left, right, up or down, and actually line it up to sort of to mate up to the bearing at the other end, and to be able to adjust it by shimming it So you get a nice free travel, the full length of the travel of the x-axis. So that's what I've managed to do with this, with a little bit of I suppose design magic. So there you go. Okay, so we have now, alright, I have made the individual parts for this end of the x-axis, so now we're going to assemble it. And I'll bring you in for a closer look to see how it goes together. Right, so we have our X bed now, or sliding bed here, with a ball screw and nut, and should we say, this is I've showed you previously in this video, quite a bit of the making of this. It's quite a nice bit of kit actually. So now what we require is a piece of equipment, or an extension housing, which this is. It's a good solid one. It's made up of two parts, these two parts here. This, as you'll understand, is a prototype, and this is prototyping. This, however, will be cast in one piece and then machined. So this goes on like so. Okay, so just hold it there. Now this is the old end cap housing, and I've actually put better bearings in it. This is a thrust bearing with a spacer block that goes in there. This is a better bearing. These bearings are made in the USA, and they're better bearings. So this actually goes on here like so. Everything is very well fitting. I should have actually put that there like that. Slide this up like so. As I say, it'd be a lot easier to put together, because it will. This aluminium extension housing section will be in one piece, not two. It gives you a very, very good indication of the kit is going to be very robust. Now, you'll see that this is semi-movable. That is to give you some degree of movement then, to be able to line everything up, because not all of these machines are made exactly the same. You must have some means of being able to slightly move things, to be able to get the x-axis to move in a very, very smooth way. Okay, make sure that's all going in there. Then there's a spacer, and a couple of these nuts go on here, and the lock nut. I will be cutting this off neatly. I might even put an end cap on here as well. When you adjust these down, really this needs to be finger tight on here. Just finger tight, just enough to pull the thrust bearing up and to eliminate all the backlash. You don't have to do this up with a spanner, okay? But as tight as you can with your fingers is fine, it's a good indication. And then you hold this one and just ease this one up to lock it, like that. Perfect. Matter of fact, probably like it a little bit looser than that. Better. You'll get the feel of it. Providing you take out all the backlash, that's really all that's necessary. It does not have to be really, really tight. That's better. That's better. So there you have basically the x-axis is. I'll bring it around this side. Okay, basically the X and the Y axis now is pretty well done. Although now this end, I've decided to put another bearing on this end in a housing, because when the x-axis is all the way over here, there's a from where the nut is here, this end, there's going to be somewhere in the region of 350, which is what, 350, but there's 300, which is 12 inches, right? There's going to be that much of screw just hanging in mid-air, and I don't like that. Although the motor is going to be on the end here, with a zero backlash coupling, if there's any flex in the screw itself, it's all going to be transmitted into this, and I don't particularly like that, so I'm going to put another bearing in a housing on this end as well. So there will be a smaller aluminium housing on this end as well, which is really just pretty well the same sort of process as I've done for making this here, this end, or this one here. So I don't want to repeat the manufacturing process or R&D process of making those houses, because it's going to get a bit boring for you. So I will make these, and then and I think I'll call it a day for this film, or this video, because I don't want to make you bored. So that's pretty well the X and Y done. The next video, what I'll do is I'll make the motor housing extensions and mount the motors on the X and Y. I want to keep them common, a common design, so the motor housing assembly will fit on the X, the Y or the Z. If it's a common common assembly, it makes it cheaper to make, and therefore makes it cheaper for you guys to purchase. So that'll be coming up next. So really, I hope you like what you've seen. In fact, I know a lot of you do are enjoying watching this, because I'm getting quite a lot of emails from you, and thank you very much, by the way, for sending all the emails. All I can say now is, as usual, if you like the video, please subscribe to my channel, press like, little red box down there, that'll take you to my YouTube channel, where there's a lot of videos now regarding CNC routers, wood turning, now CNC conversions, and I will be doing more, should we say, metal work. One of the reasons I wanted to convert this was so I could do 3D carving into metal, possibly steel or stainless steel. That would be nice. I'd like to do that. However, the CNC router that I have over there, the 6090, that is more than capable of doing 3D carving into any type of wood, plastic, aluminium, brass, copper, all the soft metals. It will do it. And I have demonstrations out there that can show you. But this little fella, this will do it in steel. That's what I want to accomplish anyway. As well as provide the kits for the belt drive conversion, and now CNC conversion. And this will be probably the smallest machine that we make a conversion kit for. They will be probably 5 different machines that will be doing kits for, ranging from this one all the way up to the Sieg X2, which is a really a machine about the same size or work envelope as a Mach 1100. But obviously it won't be Mach 1100 prices. So thank you for watching, and until next time, bye for now.